So in a typical teaching situation, you're going to want to, use whatever your operating system. Python works in most of them. This shell is written in TK, which is portable across platforms, has kind of a different look to it, works pretty well. Just enlarging the font more, because when you're projecting, so you can use it to add numbers and stuff. And then easier than in programming a calculator, because you can see more usually. That was a pretty short function. Notice how, okay, I'm having trouble deciding what to call this thing, but I want to have this syntax called list comprehension going, which is very handy for coming up with ordered pairs. If you're studying functions, ordered pairs is where it's at. So this is called list comprehension. It was taken from Haskell, I think, sort of an homage to. And so our function values haven't gone through that range. The range is a built-in primitive, and it goes up to one less, it's not inclusive at the top. And then here's another built-in called zip, and I should probably have reversed these, so this is the inverse function or whatever, but there's your set of ordered pairs, which is what functions are. Now with this second clip, you see one of the challenges of projecting from idle is you tend to get to the bottom of the screen and, can the kids in the back see stuff like that? We can talk more about that in another clip. I always encourage at least a beginning student to put one line of documentation minimum. I'm going to break that rule in a minute, but it's a good habit. And these are throwaway functions, and that we're just doing them in line in the session. We're not going to save them. Euclid's algorithm, one of the oldest in the books, and a very, very efficient way to find the greatest common divisor of any two numbers. Basically, it says if you can't divide into me, you work it out with your remainder, and then they boss it on down. You work it out, you work it out. If it gets down to 1, then there's no common factors. So we're going to use this now to come up with a function to list out what numbers less than n have no factors in common with n. We're going to use the same list comprehension syntax, just checking in the last clip, the thing from Haskell. So you got the if clause in there where we're going to filter out. We're only going to keep them if they have no factors in common. So when we want, what are the totatives of 12? Those are the numbers that have no factors in common with 12. And there's a related concept. Notice how many totatives we got there. Well, how many is that? That's the totient. The totient going to count them for us. Now, this is not an efficient way to get the totient necessarily, but it gives you a sense of the concepts, and that's what we're aiming for at this level. We're not trying to be, computer scientists.